So in this video tutorial, we want to look at this particular question on the board, and this question falls under compound event. Remember, we are still on the same topic, probability. If you haven't subscribed to the channel, kindly hit on the subscribe button for me. So let's get started. The question is, the probability that Sam, Ken, and Jojo will hit a target are 3/4, 2/5, and 1/3 respectively. If they all shoot at once, what is the probability that all of them hit the target? Only Jojo hits the target, exactly one of them hits the target, and only Sam and Ken hit the target. So we want to find the probabilities of all of these events. We have Sam, Ken, and Jojo. They have a target to hit, and their respective probabilities are given in the question. We want to base on these probabilities to find the chances, the probability, the likelihood that all of them will hit the target. Only Jojo will hit the target, exactly one of them will hit the target, and only Sam and Ken will hit the target. These are our tasks for the day, and we are going to solve it. So join me. So from the question, we have Sam, Ken, and Jojo. So let's use S for Sam, let's use K for Ken, and J for what? Jojo. So the probability that Sam will hit the target is 3 out of 4. The probability that Ken will hit the target is 2 out of 5. And then the probability that Jojo will hit the target is 1/3. We want to find the probability that all of them will hit the target. That is our first task. All of them hitting the target. Probability that all of them will hit the target. This means that we want to find the chances, the likelihood that some will shoot and hit the target, and Ken will also hit the target, and Jojo will also hit the target. So with the probability, we can write it as the probability that some will hit the target, and Ken will also hit the target, and Jojo will also hit the target. And that is going to give us the probability that all of them will hit the target. We have probability that Sam will hit the target, and Ken will also hit the target, and Jojo will also hit the target. Since we are having the and or the intersection symbol, it corresponds to the multiplication law. So we can expand this and write it as probability that Sam will hit the target multiplied by probability that Ken will hit the target multiplied by probability that Jojo will also hit the target. Now once we have this, we are just going to substitute in their corresponding probabilities. So we have probability that Sam will hit the target is 3 out of 4 multiplied by probability that Ken will hit the target multiplied by Jojo hitting the target. 6 all over 60. When you break it down, you are going to get 1 all over 10, and you can convert it to decimal to give us 0.1. So the probability that all of them will hit the target, the probability that some will hit the target, and Ken will also hit the target, and Jojo will hit the target is 1/10. Very, very easy and then simple. Now let's move on to the probability that only Jojo hits the target. Only Jojo hits the target. So probability that only Jojo hits the target means that as they are shooting, Sam will miss the target, Ken will also miss the target, and Jojo will hit the target. So it means that Sam and Ken will miss the target, and Jojo will hit the target. And that is going to give us only Jojo hitting the target. So we are going to write it as that Sam will miss the target, and Ken will also miss the target, and Jojo will hit the target. So Sam will miss the target, Ken will also miss the target, and Jojo will hit the target, and that is going to give us only Jojo hitting the target. Now we are using the S with the bar to denote the probability that Sam will miss the target, and we are using this to denote Ken missing the target. Okay, it is the same as the complement of X and then the complement of K respectively. So with this, we can write it as probability that Sam will miss the target multiplied by probability that Ken will also miss the target multiplied by Jojo will hit the target. Now we have to find probability that Sam will miss the target. Now using the complementary rule, we learned that the probability of an event occurring plus the probability of that event not occurring must give us 1. So if we want to find probability that Sam will miss the target, then we can write it as probability that Sam will hit the target plus probability that Sam will not should give us 1. Now we know that Sam hitting the target, we have 3 over 4. Then we have plus probability that Sam will miss the target is equal to 1. So from here, we can say the probability that Sam will miss the target will be given as 1 minus 3 all over 4, and that's going to give us 1 all over 4. So that is the probability that Sam will miss the target or will not hit the target is 1 over 4. Now you can also find the probability that Ken will also miss the target. So you are going to get probability that Ken will not hit the target is equal to 1 minus probability that Ken will hit the target. So we have 1 minus 2 over 5. That gives us 3 all over 5. So probability that Ken will not hit the target is 3 over 5. Now once we have this and that, we can substitute it in place of that, and then we do our multiplication. So we are going to have 1 over 4 multiplied by 3 over 5 multiplied by P of J 1 over 3. When you multiply them, we are going to get 3 all over 60. When you simplify, you are going to get 1 all over 20. So the probability that only Jojo hits the target is 1 over 20. Very, very easy and simple. So we want to look at the probability that exactly one of them hits the target. Exactly one. We want only one of them to hit the target. We are having 3 people, Sam, Ken, and Jojo. We don't know which one of them is going to hit the target, but we want one of them to hit the target. So which one of them? In constructing the probabilities, we can say that the probability that Sam hits the target and Ken missed the target and Jojo also missed the target. So within that event, only one of them hit the target, and that is Sam. Or you can say that Sam missed the target and Ken hit the target and Jojo missed the target. In that event as well, it is only one of them who hit the target, and that is Ken. Or we can say that Jojo hit the target and then Sam and Ken missed the target. So within all of that, we can say that it is only one of them that is hitting the target. So we can write it as probability that Sam hit the target and Ken missed the target and Jojo also missed the target. So within this event, you can see that it is only one of them, or exactly one of them, hitting the target, and that is what? Sam. Or it can happen that Sam will miss the target, and Ken will hit the target, and Jojo will miss the target. Or it can also happen that Sam will miss the target, and Ken will also miss the target, and Jojo will hit the target. So within each of these events, one of them, or exactly one of them, is hitting the target. With this event, it is Sam who is hitting the target. In this one, it is only Ken who is hitting the target, and with this one, it is only Jojo who is what? Hitting the target. So we have exactly one of them hitting the target. So we have probability that Sam will hit the target multiplied by P of K complement multiplied by P of J complement. This all means the addition symbol. So we have probability that Sam will miss multiplied by Ken multiplied by P of J complement. We have all, which is the same as plus. Then we have P of X complement multiplied by P of K complement multiplied by P of J. So once we have this, we just have to substitute in their corresponding probabilities. P of X, we have 3 over 4. P of K complement, we had 3 all over 5. P of J complement, we had 2 all over 3. Then we have plus. P of X complement, we had 1 over 4. P of K, we have 2 all over 5. P of J complement, we had 2 all over 3. Then we have plus. P of S complement, we had 1 all over 4. P of K complement, we had 3 all over 5. P of J, we had 1 over 3. Now once we have this, we just have to multiply them. This is going to give us 18 all over 60. This is also giving us 4 all over 60. And this will give us 3 all over 60. Seeing the denominators are the same, we can pick one of the denominators. We add the numerators, so we have 25 all over 60. When you break it down, you have 5 all over 12. So the probability that exactly one of them hits the target is 5 all over 12. Very, very easy. And then as easy as A, B, C, D. Let's look at only Sam and Ken hitting the target. So with the probability that only Sam and Ken hit the target means that Sam will hit the target and Ken will also hit the target. And Jojo will miss the target. And that's going to give you only Sam and Ken hitting the target. It means that these two people will hit the target and Jojo will miss the target. So we can write it as the probability that Sam will hit the target and Ken will also hit the target and Jojo will miss the target. Since we are having the intersection, it corresponds to the multiplication law. We can write it as probability that S hitting the target multiplied by probability that K hit the target multiplied by probability that Jojo missed the target. So once we have this, we substitute in their corresponding probabilities. P of x, we have 3 over 4. P of k, we have 2 over 5. Jojo, missing the target, we have 2 all over 3. So when you do your multiplication, this will give us 6. 6 times 2, we have 12. 12 all over 60. So 12 into itself 1, and then into 60 we have 5. So we have 1 all over 5. So the probability that only some and can hit the target is 1 out of 5. Very, very easy. This brings us to the end of today's lesson. See you tomorrow. Bye-bye.